Let's see how to use F equals to ma to solve this particular problem. What horizontal force F, that's that one, must be constantly applied to a 20 kg object, that is this trolley right there, so that M1 with a mass 6 kg and M2 with 3 kg do not move relative to the trolley. Assume no friction is involved. The main idea here is simple. If M1 and M2 are to be stationary with respect to the trolley, then all these three objects must move as a single system with the same acceleration. Let's call it A. The best way to do this problem is by analyzing the free body diagrams. Now, how many free body diagrams are there? There are three masses, so there must be three. So to begin with, let's look at the free body diagram of M2. So what are the forces that's acting on M2? The obvious one is its weight. Let's call it M2G, where G is the gravitational acceleration. And the other one is tension in the string, T, like that. And the third force is the force from capital M, normal force. Let's call it N2. The origin of N2 is because since M2 is pressing on M on the side and therefore exerting certain force like that on M, M in return will press against M2, and that N2 is that force. It's like an action-reaction pair. The next thing to note is that this M2 has an acceleration A as the system collectively move to the right. From the free body diagram of M2, we can immediately see tension must be the same as the weight of M2 because M2 is not supposed to move up or down. It is stationary with respect to capital M. So we write tension equals to M2G. The other thing is, since the only rightward force on M2 is N2, this N2 is related to the rightward acceleration. So the net force in a rightward direction on M2 is N2, and that equals to M2A by Newton's second law. Next, let's look at the free body diagram of mass M1. That's that mass. The first force that is acting directly on M1 is its own weight. Let's call that M1G. And then there is this tension in the string that connects M1 through pulley to M2, and that is T. Since this is the same string, so this T must be the same as that T. The third force on M1 is the normal force from capital M that is heading like that. Let's call that N1. Because M1 is pressing on capital M, M will in return press against M1 with that much force. So that is the normal force in an upward direction on M1. And M1 will also move to the right, collectively as one system with an acceleration A. So vertically, N1 must balance M1G, because M1 is not moving like that. So immediately we write N1 equals M1G. And the only rightward force on M1 is the tension. So T equals MA, in this case that M is M1A. This is Newton's second law. Since M1 has the same acceleration, A, as the capital M, it does not have any sideways motion with respect to capital M as well. Before we proceed further, for future use, we note that tension equals M1A, but from the free body diagram of object M2, tension also equals to M2G. By equating the two, we get the following result. And solving for A, we get A to be M2 over M1 times G. So A can be expressed in terms purely of known quantities. And let's write this result here. Finally, let's look at the free body diagram of the trolley with mass capital M. So what are the forces? The horizontal force F that is acting directly on that trolley, that's one. The second force is its weight, capital M times G. The third force is the force with which M1 presses on capital M, and that is the same as N1, like that. And we know N1 equals to M1G, so let's label that as M1G. And the fourth force is the force with which M2 is pressing on M. We know M presses against M2 with a normal force of N2, so the same force should also act like that on capital M. So let's use the same symbol N2. And of course, capital M moves to the right with acceleration A. On top of all that, there is a normal force from the ground acting in an upward direction on the trolley, like that. You can call that capital N. So by balancing the force, we know capital N equals mg plus m1g. We don't really use this result, but it's nice to recognize this equation. What's more important is the rightward force. There are two. One is the capital F that we want to determine, and the other one is N2. So the net force acting on capital M is F minus N2 in a rightward direction, and that equals to the total mass that one can attribute to this trolley, not just capital M, but on top of that, that also contributes, little m1 times A. Note that the little m1 is on top of capital M, so the effective mass of capital M is m plus m1. Now we can calculate the expression or the value for capital F. N2 can be obtained from here. So that means capital F equals N2, which is m2 times acceleration, and acceleration have been determined as m2 over m1 times gravity plus the second term, capital M plus little m1 times again the acceleration, m2 over m1 times gravity. Let's simplify this expression. F equals, you take out the common factors, which is m2 over m1 times g, and to that we multiply m2 plus capital M plus m1. So now let's put in all the numbers. m2 is given to be 3 kg, so 3. m1 is 6 kg, so 3 over 6 times gravity. m2 is again 3 kg, plus capital M is 20, plus little m is 6 kg. So 20 plus 6 plus 3, so that is 29 kg. And you end up with a final expression, 14.5 times gravitational acceleration. And if you take g to be 9.81, F would become 142.2 newtons approximately. And that's the final answer, and that solves the problem. As always, thank you for watching.